Yes, students. Good morning. Today we are going to discuss about network performance, self-learning topic in first unit. Okay. So the network performance may be measured through how much delay per transmission, how much throughput is producing, and how much jitter is there. According to that, how much waiting time is there. So all the factors we are going to discuss in this video. You just watch it. In unit 1, we are going to discuss about performance. This is self-learning topic 6. So before going to discuss about this video lecture, we must be know about lecture outcome of this video. After listening to this video lecture, you will be able to calculate the performance of the given network based on the bandwidth, throughput, latency, and jitter. That means in this video lecture, we are going to discuss about what is bandwidth, how we can measure the bandwidth, and throughput, latency, and jitter. So before going to discuss about bandwidth, we must be know that propagation time. What is propagation time? Okay. The propagation time measures the time required for bit to travel from the source to the destination. Okay. So that means this is the source, this is the destination. So how much time it is required to travel a bit from source to destination? Okay, so how much time is taken from reach a bit from source to destination? That is propagation time. Propagation time is calculated by dividing the distance by the propagation speed. Okay, so how much distance it is there divided by the entire propagation speed will be calculated as propagation time. Okay. The propagation speed of electromagnetic signal depends on the medium and on the frequency of the signal. Okay, how much frequency the signal have, as well as the medium, how what is the speed the signal is transmitting in the medium. So according to that, we can calculate the propagation time. For example, in a vacuum, light is propagated with a speed of 3 into 10 power 8 meter per second. Okay, so it is lower in air, it is much lower in cable. Okay, so while it is used in the vacuum only, it is used this much speed. If it is in the air, it is again lower. If it is in the cable, again it is lower. Okay, so this is the propagation. In networking, we use the term bandwidth in two contexts. So now we are going to discuss about bandwidth. First one, bandwidth in hertz. Okay, so we know the hertz is that we are using for mentioning the hertz refers to range of the frequency in a composite signal or the range of the frequency that a channel can pass. Okay, the range we can mention it in the particular channel, how much hertz it is possible. So for example, subscriber telephone line is there, so that how much speed it is transmitted, 4 kilohertz. Okay, so it is bandwidth of the subscriber telephone ID is 4 kilohertz. That means 4000 hertz, the signal strength or frequency of the signal. We can say that 4000 hertz. Next point is bandwidth in bits per seconds. Okay, so first one is when we are thinking about the signals, it may be the analog signal, it may be represented using hertz. So based on that, we can calculate. Second one is bits per second. Per second, how much bits are transmitted? Accordingly, we can calculate it. Okay. So what is that? Bandwidth in bits per second refers to the speed of bit transmission in a channel. Okay, how much speed it is transmitted. For example, if the cable is there, okay, so how much speed the data may be transmitted this channel. Okay, so if you example fast Ethernet cable means this cable have the capabilities of 100 megabits per second. So the channel capacity. So we are saying that capacity of the channel, that is also we can say that bandwidth of the Ethernet cable is 100 Mbps. Next one, throughput. What is the throughput? The bandwidth is potential measurement of the link. The throughput is an actual measurement of how fast we can send the data. Okay, so that means in a particular time, how much data we are transmitted. Okay, so source is there, destination is there. How many, not timing. In a particular time, how many data or how much data we are transmitted from source to destination, that is throughput. Okay. For example, we may have link with a bandwidth of 1 Mbps. Okay, the link means wire have the capability is 1 Mbps. That means 1 megabytes per second. But the device connected to the end of the link may handle only 200 kbps. What is the meaning of that? The wire is have the capability of sending 1 megabytes per second. Okay, this entire cable length capacity. But the receiver which is connected here have the capacity to receive only 200 kbps. Okay. So what it is? This means that we cannot send more than 200 kilobits per second through this link. Okay. Even if we are sending more also, the destination is not reaching it. So we can send only 200 kbps. The bandwidth is 1 Mbps, but throughput is how much data we are transmitted, 200 kbps. So if example, the highway is designed like 1000 cars per minute it will moving. The capacity is 1000 cars per minute it will be moved. But what happen normally? So we can say that 100 cars per minute. Why? Due to congestion. If we are given 1000 cars in a road, what happen? The road will be filled. Congestion may be occurred. Due to that reason, we send only 100 cars per minute. The bandwidth is 100 cars per minute. The throughput is, the bandwidth is 1000 cars per minute. The throughput is 100 cars per minute. That is here. Bandwidth is 1 Mbps. Throughput is 200 kbps. Okay. So now we will see simple examples. A network with bandwidth of 10 Mbps can pass only on average of 12,000 frames per minute. Okay, so what they are saying that one channel is there. Okay, this channel we are able to transmit 10 megabytes per second. This is the entire bandwidth. Okay, so 12,000 frames per minute is there. Per minute they are saying. Okay, 12,000 frames per minute. With each frame carrying average of 10,000 bits. Okay, so how many bits are there? 12,000 frames, and each frames have 10,000 bits. So we have to calculate total number of bits. Then what is the capacity? 10 Mbps. Okay, so how to find it? Like 12,000 frames into 10,000 bits, total bits per minute. They are saying per minutes, but we want that per seconds. Okay, so what is that? Here they are given, no, per minutes they are given, but we will calculate it bits per seconds. So 10 Mbps capacity is there, but how much data we are transmitting? So here 60 is there. When we are calculating 120 lakhs divided by 60. If we are calculating that, finally we are getting it 2 into 10 power 6 bits per second. This is the answer actually. Okay. So whenever we are getting 10 power 6, we can use megabits. Okay. The throughput is almost 1/5 of the bandwidth in this case. So 10 Mbps is possible. This channel have 10 Mbps capacity, but we are sending only 2 Mbps. So we can say that simply in your classrooms, 60 benches are there. Okay, that is bandwidth of the class. If the class students have tutorial hour, okay, so example you consider tutorial hour, batch of students, 32 students only, they are occupied that classroom. This is true. Okay. So now latency. What is latency? Latency means a delay. How much late it is taking to reach the destination. Latency or delay defines how long it takes for an entire message to completely arrive at the destination. So if we are sending 2 MB of data, okay, from source side, so finally, how much time it is taken to reach all 2 MB in destination? Okay, so that is latency or delay. From the time the first bit is sent from source side, first bit it is sending now up to starting this time to reach last bit here. Okay, the destination last bit send out from the source. Clear? So completely receiving total 2 MB is considered as the latency or delay. So what is the meaning of that? 2 MB is there. Okay. So 2 MB means 2 lakhs. Sorry, 20 lakhs of bits are there. So first bit it is starting now. That time we have to consider. So while first bit reaching, we don't want to consider up to last 20 lakhs bit. 20 lakhs bit is there, no, that bit you can take it. That much time is considered as the latency of the data. So we can say that latency is made of 4 components: propagation time, transmission time, queuing time, and processing delay. So for example, what is the propagation time if the distance between 2 points is 12,000 kilometers? Okay. So the source is here, destination is here, the distance is 12,000 kilometers. Okay, totally 12,000 kilometers. So what is the propagation speed? Propagation speed means this is the speed it is used in the cable, 2.4 into 10 power 8 meter per second. So how we can calculate 12,000 kilometer? Yes. So meter per seconds, no. So we have to convert it into thousands. 12,000 kilometers into meters. So that's why we are multiplying with 1000. And this is the propagation speed, 2.4 into 10 power 8. Finally, we are getting 50 milliseconds. The example shows that it can go over the Atlantic Ocean only 50 milliseconds if there is a direct cable between the source and destination. So 12,000 kilometer you can consider from source to destination. If direct link is there means what is the propagation time? 50 milliseconds. Now transmission time. What is the transmission time? In data communication, we don't send just one bit. We send a message. Okay. The first bit may take a time equal to the propagation time to reach its destination, and last bit also may take the same amount of time. Okay. The source is there, destination is there. How much time it is taking by source? First bit is reaching to the destination. The same timing it will take for last bit to reach the destination. Okay. Do you understand this? However, there is a time between first bit leaving the sender. Here, first bit when it is leaving from source, leaving means start to send, leaving to source, and last bit arriving at the receiver. This is the transmission time I already told. Okay. So in case the first bit leaves earlier and arrives earlier, the last bit leaves later and arrives later. We know that. The transmission time of a message depends on the size of the message and the bandwidth of the channel. So how to calculate transmission time? Total size of the message and bandwidth of the channel. For example, what are the propagation time and transmission time for a 2.5 kilobyte message? Okay, 2.5 kilobyte. Kilobyte means 1000 bytes. Assume that the distance between the sender and the receiver is 12,000 kilometers. Okay. And that light travels at, this is 10.8, 10 power 8. Okay. So what is the formula we have to calculate? So simply we can use that formula. We know that 12,000 into 1000 because kilometer, that will be converted into the meter. Propagation time we have calculated already, we know that. So now what we are doing this 2500. Why? Because so 2.5 into 1000 means bytes, we are converted into bytes. So 2500 bytes. Each byte have 8 bits. Okay, so 2000 bytes and each byte have 8 bits. So we are converted into bytes, bits, then divided by 10 power 9. Okay. Why? 1 gigabits per second. The network speed is capacity. The bandwidth is gigabits per second. What is the gigabit? 10 power 9. Okay, bits per second. That is gigabits per second. So finally we are getting 0.020 milliseconds is the transmission time. So I will give one problem now. What are the propagation time and transmission time for a 5 megabyte message if bandwidth of the network is 1 Mbps? Assume that the distance between the sender and receiver is 12,000 km and light travels at 2.4 into 10 power 8 milliseconds. Okay, so you just try it, then we will discuss in the class. You must be come with the solution for this problem. So next one is queuing. So what is queuing time? So for latency, we must be calculate queuing time also. Time needed for each intermediate or end devices to hold the message before it can be processed. So source is there, intermediate some nodes are there. Finally, it's a destination. The message maybe comes here, it will be processed. The message, then it will reach here, it will be processed here, then it will send here, it will process, then it will reach. So till the processing of the packet, the remaining messages or bits will be wait. Okay, so that is the queuing time. Clear. Queuing time is not fixed factor. It changes with the load imposed onto the network. When there is a heavy traffic on the network, the queuing time is increases. If more packets are processing means the remaining packets will wait here. Okay, so the first packet is processing. Then these three packets are will wait there. So again, same like that. If it is free here, there is no traffic, then it will have less queuing time here. But here it is traffic already. Some packet message, sorry, bits are waiting. Then the new bits are coming here. Then the queuing time is more here. Okay. What are the intermediate devices we are using in the network? Routers use arrived messages, process them one by one. So intermediate device will do this operation. Okay. If there are many messages, each message will have to wait. Last one is jitter. What is jitter? Already we have discussed about that. The deviation between the delay. Okay. So first packet it will take some 20 milliseconds. Second packet maybe it's taking 45 milliseconds, and third packet maybe reach 40 milliseconds, like that. The variation on the delay is called like jitters. So now we are in the end of this video lecture. So now we can revisit the lecture outcome. Now you can, okay, so you can calculate the performance of the given network based on the bandwidth, throughput, latency, and data. If I will give the capacity of the medium as well as the network number of nodes source to destination, you can calculate the bandwidth of the channel or throughput of the network, latency of the transmissions. So those things we will calculate it. Some sample questions for that. What is the propagation time? If I want to send the data from Telangana to Tamil Nadu, I am in Telangana, I want to send some data to Tamil Nadu. So what is the propagation time I'm asking? The propagation speed I will give is, sorry, this is again 10 power 8 meter per second in cable. Okay. So what is the propagation time? You have to calculate them. Okay. So example, what you have to do? Telangana to Tamil Nadu, you have to find the distance. For example, if 650 kilometers means then 6,000, sorry, 6 lakhs and 50,000 meters. You have to convert into the meters and divided by 2.6 into 10 power 8. Okay. 2.6 into 10 power 8. Next question. A network with bandwidth of 20 kilobits per second, bandwidth they are given, that is overall capacity, 20,000 bits per second, can pass only on average of 10,000 frames per minute. 10,000 frames. Okay, 10,000 frames per minute. So 10,000 frames per minute means 60. Okay, 60 seconds. So if you want to convert it means 10,000 by 60. And each frame carrying average of 10,000 bits. So 10,000 frames are there and 10,000 bits are there. Okay, what is the throughput of this network? So per minute you have to calculate 10,000 into 10,000 by 60. Okay, so that is the throughput. Thank you very much for listening this video lecture. The next class we will see about next SLT. Thank you very much. So the next SLT is 7, data link layer introduction in unit 2. So as of now, unit 1 is forward. Thank you very much.